So when we're solving a one-step equation, our goal is to try and get the variable by itself. So in this case, we're looking at the variable b, and we want to isolate the variable so that we know what it is equivalent to. So when we look here, we know we have to get rid of this minus 5. So we want to do the opposite of a minus 5. So we need to figure out what the inverse operation is for subtraction. And to undo subtraction, we're going to add. So we will add 5 to both sides of our equation. It's important that we remember the equal sign is our dividing point of the equation. So that means if I add 5 on the left side, I have to add 5 on the right side of the equal sign. So that way everything is going to stay balanced. So now when I go back and look at this equation and I simplify it, I know this negative 5 plus 5 will cancel out to 0, which will leave me with b, and 7 plus 5 will give me 12. So b is going to be equivalent to 12. So now if I want to check this, I can go back to my original equation, but instead of b, I'm going to substitute the 12 in. So when I take my b and put 12, which is my value for b, and I subtract 5, I want to get 7. So we check that and make sure it works. And 12 minus 5 is 7. So we have found the correct value for our variable b. In example 2, they've given us a diagram to look at here, and we have a triangle. If you notice, they have these little hash marks, and those hash marks are telling us that these two sides are equal. This is called an isosceles triangle. So we know that 11 is equal to 6 plus a. So we can set up our equation by setting those two values equal to each other. So again, we're looking for our variable here, which in this case is going to be a, and we need to isolate a. So we have to get rid of this plus 6. So I have a positive 6 here that I want to get rid of. So thinking inverse operations, the opposite of a positive 6 is a negative 6. So I'm going to take 6 away from each side of the equal sign. Again, make sure you're looking at both sides of the equal sign. I'm going to take 6 away from the 11, and I'm going to take 6 away from the 6 plus a. By doing that, the 6 and the negative 6 are going to cancel, which will just leave me my value of a. 11 minus 6 will give me a value of 5. So again, I have my value for my variable a. If I want to plug that back in to make sure I've done this correctly, I go back to my original equation, but instead of a here, I'm going to substitute in 5, which we said was the value of a. So when I plug that in, I can check that 6 plus 5 does equal 11, and I have done the problem correctly.